Hello there. My name is Chris Fernandez. I'm a solutions engineer with Keysight Technologies. Today I'm just going to go over our continuing on our discussion about testing TSN using the NXP board, the ls1028ardb, and our IX network and our Novus cards. So today I'm going to be talking about 802.1 QCI, which is the filter and policing aspect of TSN. So when you're thinking about TSN in terms of all these protocols that are available, the QCI, the main primary goal of it is to protect the network in terms of blocking traffic that you don't want to exceed or even want to get into the network. That means that you put that QCI configuration on the ingress interface. And it's not like QBV, for example, where you put the stuff on the egress port, where you classify the traffic based on queues and priorities, and then you send it out in the correct spot. The way that QCI work, it's more about policing. So you attach a traffic stream per stream. So you kind of classify the traffic on. You can do it on the Mac. That's what we're going to show to you, or it can be on a VLAN and IP and so on, depending on your implementation. You think QCI is more like a bouncer in a bar, right? Lets you in or lets somebody in, or not many people in at the same time. Think of it as a bouncer inside in the door, the entry door of your network. So it's kind of protecting your network from the outside, right? So I'm a visual person, so I like to put stuff on your display here. So I'm using on the right side of the screen here, you're gonna see I have four ports, 1, 2, 3, and 4, and they're connected to my NXP switch. So if you look on the back of the NXP switch, I have one that's a management port, and then 1, 2, 3, 4 are my connections here to my NXP. So I'm going to be using the SPW0 here as my master, so my talker, right? And all those three here is going to be my listener. And I'm going to try to demonstrate the three aspects, or three of the aspects of the policy and filtering capabilities of QCI, right? So first things first, I need to have a PTP running on them. So right now you can see here I have a master clock on this PTP on this SW0 here, but all the other ones don't have anything. So I'm gonna start PTP on my NXP switch, and hopefully all my followers are gonna be listening too, and we are synchronized. And then you're gonna ask, why are we synchronized? Because one of the aspects of QCI is gating, is to say I'm only going to accept traffic from, let's say, 0 to 100 microseconds, which was I'm going to show on the demo here. And so the synchronization is still part of this configuration, right? So I'm just going to start PTP on all the ports, and we can see that everything is going to turn green. So fgptp.sh start. So that will start my PTP on my bridge. So that should bring everybody up. So everybody now is connected. So my PTP, so all my ports are synchronized. Now at this point here, I don't have any QCI configuration, and I have three traffic items that I'm going to be showing as a demo, right? The first one is policing. Policy means I'm going to policy the rate of the traffic coming in. In my case here, I'm going to send, let's say I'm going to apply a policy that's 10 megabits per second. So anything above that, I'm going to drop, with a little exception on the burst. I think I did a 10K burst. Okay, so let's go to the first one. First, to demonstrate that I don't have any QCI configurations on anything here, I'm just going to send this traffic here. So I have 10,000 packets for each of those demos here. So the demo is first is to show you policing, how policing works, and then is to show the gating, how the gating works, and then blocking. The blocking here is kind of a fuzzy implementation that I had to do on my NXP switch. I kind of had to do, instead of doing the policy that says block this traffic, I had to use like a really strict policy because I could not get the drop to work. Maybe it's something on my end, but at least it demonstrates well what blocking does. So anyway, let's start with just sending traffic. So I'm going to send 10,000 frames for each of those 3 demos that I'm going to be using eventually. And we can, now there is no configuration on the UT. So the traffic should flow and nothing should happen, right? So I send 10,000 here and 10,000 for those 2 other streams, and everything should go through. On the terms of the topology itself, I can show you here. I have, we're doing a layer 2 routing only. So think about, so this here is my 1102. This here is going to be 1202. This is the one that I'm going to be using for bandwidth testing. The one that I'm going to be using for the gate testing is going to be 1302, and the one that I'm going to be blocking is going to be 1402. You're going to see those MAC addresses. That's how I map the policing to those particular streams. The way Keysight works is that if a traffic coming in does not match any of my policies, that means that I'm just going to send it over to the switch, and the switch will have to deal with it. In terms of implementation, so the best policy would be to have a third policy that will catch all and drop it all if it's not something that you expect. But for simplicity and for demo's sake here, I'm just using the 3 matching here, so I can do whatever I need to do with my traffic. Plus, as you know, the PTP traffic doesn't have VLAN to it, so that is why whatever policies I apply, it does not affect the PTP traffic. So that's why I didn't want to do a catch-all and drop everything, because that would take a little bit longer to implement. So so just for sake of implementation, all the traffic here is going to go through, so I'm not doing anything. So 10,000 for all 3 policies, right? So my script, let me go in here, it should be under QCI. And I'm just going to execute the script here, and I can kind of show you what the script is doing. Let me go actually do a cat on what I just did, so you guys can see what was the configurations that I did. So this is my script that's running. As you can see here, I'm using the ingress port 0 and 1, 2, and 3 on my on my DUT. So the first scenario here is the stream. So I am catching, I'm doing a rate limiting of 10 meg for this particular MAC address. So I'm looking at a MAC address coming in, and I'm doing a flow rate limiting to it to 10 meg, and the size burst is going to be 10K. So 10K I'll let in, but and then after that I'll kind of block it and drop it, right? And the implementation for that code is over here on the scenario here right now. It's called scenario 3, but it's really what I'm doing for the get-go, just for sake of showing here. So for the first demo, now I have this configuration running on my DUT. So let me just do this here so we can take a look at the rates, how it shows. So it's going to be so SWP0 and ingress chain 3. All right, so this is kind of gives us the packets and so on, right? So right now everything is 0 because I just used this. So for sake of the first test, I'm gonna take this out. I'm gonna take the other 2 out. So we'll just demo the policy here. And what I'm gonna do here under my rate setup for this particular, I'm doing the setup as 20 meg or 20 meg. So if I do this, I supposed to lose 50% because I'm about 50%, right? The 10 meg plus the 10K burst. So let's first do something that is below. So I'll do 8 meg. So what I expect is that I am gonna get all of it because it's below my policing, right? So I'm gonna do an apply here, and this is the only traffic I'm gonna send now. So it's only gonna be 10,000 packets, and I'm expecting to be 10,000, and I shouldn't drop anything because I'm below the 10 meg. So I'm gonna click send. It should be really quick, and we can take a look at the rates here, right? So it's going to be really quick. It's going to send for maybe 1-2 seconds and stop. All right, so the traffic already stopped. So as you can see here, I sent 10,000 packets. I received 10,000 packets because I set my rate to below 10. So over here, if we take a look at the my policy here, right? So I sent 10,000 packets. I dropped nothing, right? Because everything was great. Everything was under my my 10 meg limit. Now let's say I do the same test, but I'm going to change my rate now to let's do 20 because that's or a little bit more. So let's do 20 so it's easier to implement, right? So if I do 20 here, 20 meg, I'm expecting to lose about 50%, right? So I'm going to click this and I'll do finish here. And now what I'm going to see is that I'm going to lose about 50% of the traffic. There is some buffering there for 10K, but and those packets are about, I think those packets are 100 meg, but give it or take about 50%. So I'm going to send that out again and see what happens. At this time, I'm not expecting to get it all, so I'm expecting that the policing now is going to be taking over because I'm sending over 10 meg. So I'll leave the traffic running here for, it will be 4 seconds or so, and then we can check on both on the DUT and over here. So over here, I'm going to be probably around a little bit over 5,000 packets. Yep, 5,003. So I lost about 50% of the traffic, right? And over here now we can look at it again, and now I see that the drops here are exactly matching what I was expecting here. So 49.57 got dropped. 49.57 is the delta, right? So I exceeded my 10 meg of policing, and that's why I see those drops here in this second policy here. All right, so for so now I did this using frame rates 10,000, right? So we can do this using continuous, and you're going to see about the same thing, but that kind of demonstrate the policing aspect of QCI. Okay, so let's move on to the second one now. So the second one, I'm going to disable this one and I'm going to enable this one here. So this is my second demo. So my second demo says that let's go back to the script. So the second demo, which is applying the gating rule, right? So the gate is that I am going to be sending traffic, and I'm going to have a cycle time of 1 millisecond. And I'm going to say that I think I did right here of, so yeah, so I'm opening the gate for only between 0 and 100 microseconds. So then after that, the gate is closed. In QCI, what happens is it's different than QBV, where you buffer the traffic and you wait for the gate to open again and send it, right? It's kind of the next cycle you'll send the traffic. On QCI is different. If the traffic does not come in at the exact window, you will drop the traffic. So that's what we're going to try to demonstrate here. So this scenario is the gating one, and I'm using 1302 as my MAC address that I'm attaching to, and I'm doing the gate. So the gate is between 0 and 100. I'll let the traffic in. After that, I'll drop the traffic. So I'm going to be synchronizing. So my PTP is synchronized, and I'm going to send traffic. And it should go right through it because I don't have my my offset is 0. I'm sending the traffic right at the start. So between 0 and 100, the traffic should go through without any issues, right? And I'm sending it 10,000 packets per second. So if I send this, everything should work. We can take a look at the policy here after that. So let's do that. I'll let traffic flow through first. So just wait for the traffic to go through. I'm expecting all the traffic to go through, and no issues, right? So look at the folder statistics here, and it should work. So the gate between 0 and 100. So I'm sending traffic, and traffic is flowing right along, right? No problem. I got my 10,000 packets. So now I can look at my stats again. So this here was for this particular IP MAC address, right? So you can see here my 10,000 packets sent out. Everything worked. Here's my gate open, and my gate closed. So everything worked fine, just as expected. So now we're going to change the gates, right? Or not, sorry, we're going to change the scheduling, how we're sending the traffic. And we're sending now the traffic. Let's now send the traffic at the wrong time. So let's say I'm going to do this at 200 microseconds, right? So when the packet arrives there, the gate should be closed. What my expectation is that now this traffic here should now be blocked, because the gate now is closed at that time, right? So I'm going to apply this, and I'm going to send it again. And at this time, I expect 0 traffic to go through. QCI is not as nice as QBV, I guess, and it will not buffer. What I'm saying is not nice because it's the main policy, the main goal here for Keysight is to protect the network, right? We're doing this at hardware level, so we're not sending to the CPU to do any type of analysis or anything. This is blocking at the hardware level. So I'm going to send this traffic again, and I'm expecting 0 traffic to go through and everything to be blocked, because now it's coming in, the traffic is coming in at the wrong time. So the policy here says nope, no traffic should flow through, and the traffic now is being blocked completely because I'm getting here at the wrong time, right? So this is exactly what I expect, and we can see it again here on my policies for 1302 that the traffic got now dropped 10,000. So this demonstrates the gating aspect of QCI. Now the third and last demo here I'm going to do is about the 14 here. This is my third port. In terms of the script itself, I didn't have a nice way to actually block the gate, so I had to use a policy that is completely unattainable, like it just blocks everything. But it's not, this is just a limitation of maybe on my end, but the goal is the same. I'm not going to allow traffic to go through if it's from this MAC address here, right? So this MAC address, I'm not going to allow the traffic to go through. So to demonstrate that, I'm going to go and traffic item. I'm going to stop this. I'm going to enable this here, the blocking traffic. And you can see here under, if I do a preview here, you can see the MAC address of my destination. So this is the destination, is 001402. So this matches exactly what we're doing here. That's why this traffic should be blocked, right? I should not allow any traffic to go through, no matter what the gate does. I'm not doing any gating here for this particular MAC address, right? So I'm going to say finish, and when I send this traffic here, I'm expecting nothing to go through, and I'm expecting the drop here to go to 10,000. So let's see here. The traffic is going to flow through, and then we can go back to and look at the DUT stats. So I'm sending, let's say, 10,000 packets. So nothing's going through, and everything should be blocked, right? So I'm waiting a couple more seconds. I can look at my stats here, and my stats here says exactly what I did. I dropped every MAC address with this particular MAC address. Now, in order to demonstrate that first point that I told you about, QCI depends on filtering per stream and looking at a particular MAC address and so on. What we can do to change this point here very quickly is if we go in here under packet and try to change the MAC address. So let me do this here, do the cancel here. on the over here, I'm just going to change this to 2. Right, so that changed to 2, and I changed that. That gonna make sure now I can go into my traffic item here and kind of regenerate this. If I regenerate this, I'm hoping that my preview now it's 2. Let's see if that worked. Yep. So now my destination is 2. And this here is a traffic that is not being, it's not going to match any of my filters here. So it should flow right through. Given to the switch, the switch is actually going to do a flooding because he doesn't know what that 02 is going, but the traffic should go right through it. And that's exactly what I'm expecting. So let's see here if that is the case. And there we go. So now the traffic goes right through it. Keysight is working as designed. Anyway, I hope this demo was good. I'll put a link of my Keysight demo v3 configuration for the Ixia and the script itself that I use on my NXP switch. My NXP switch by default has the VLAN 100 on my bridge, and that's pretty much it. And of course the whole suite of TSN for my switch. All right, I hope this video was helpful. Let me know if you have any questions. Feel free to reach out for us if you need any additional information. Thank you.